1, go. Is it recording? Yeah. Ah, shoot. There we go. Yeah. Oh, yeah. Well, I'll edit this, I guess. All right. So, where were we? So we have this contingency table within, and we have the expected frequency and the observed frequency. Okay. So I want to examine these real quickly. This is not a slide. I added this slide. Okay. An observed frequency table is one that you collect the data. An expected frequency table is the one that you calculate the expected frequencies. So here's a generic look at an expected frequency table right here. So what this is, you have A and C, A multiplied by C divided by N. Okay? This is important. Okay? But if you did this with the example already, fine. If you want to watch the video and look at this, fine. If you want to look at the notes online, you can. Okay? But basically you see how these come together. Boom. Multiply, divide by N. Make sense?
Yeah.
So that's a real quick way of calculating that value. Also, before we continue, the chi-squared test determines the difference between the observed values obtained from our sample and the expected values we have recently calculated. Therefore, we have this calculation. Okay? Chi-squared calculated equals the sum of frequency observed minus frequency expected, frequency expected squared over frequency expected, all that summed up. Okay? It's all that summed up. And once again, F sub O is observed, F sub E is expected. If the variables are independent of each other, that means that that contingency table that we have, those values are really close. So there wouldn't be much variability. That F sub 0 minus F sub 0, F sub O minus F sub E would be tiny, right? There wouldn't be much variation. It'd be tiny, and so our chi-squared calculated would be low. Okay? That's if they're independent. If they are dependent, if they are not independent of each other, or dependent on each other, the observed values would differ a lot. Right? I went out, I observed the values, they're way different than my expected values, and so we get a calculated value that's really large. That's really important to understand. So, if we're looking to see if they are dependent on each other, we want our calculated chi-squared value to be high. Okay? We want it to vary more. And that makes it dependent. Okay? Or not independent. Now, let's continue with what we had before. Okay? So, we want to find the sum of the frequency observed minus the frequency of the expected value squared, and then divide it by the frequency of the expected value. We need to fill in the table, top row, first column, and then continue rows, then rows. We go by row. So, for instance, this top portion right here would be the first row, first column, first row, second column, second row, first column, second row, second column. Okay? If I was to draw this out, we put it in order 1, 2, 3, 4. Okay? That corresponds with 1, 2, 3, 4. See how that works?
I'm really confused.
What? No, this first spot in the contingency table for the observed goes here. In the contingency table, the one that we just looked at. Okay? So that's why that's 60. Look at your notes. What? You read it like a book. There you go. Read it like a book. Same thing for the second one. The frequency of the expected values are there in front of us. Okay? So now we're going to take those values and subtract them. We'll get negative numbers and positive numbers, but check out what happens. What happens? Well, they're all the same digit. Okay? So if that's the case and we square those values, shouldn't the squared values all be the same as well? They sure are. And now the last step of the calculation is to take each of these values that we just calculated, 1879.22, and divide it by f sub e. But all of those are different. So these calculations will be all different. And after we finish that, we can sum it up, and that will be our chi-squared calculated. Okay? So our chi-squared calculated is 75.48. Yes?
We're going to be able to do this on a calculator, but still by hand.
Eventually,
like
yeah.
we do with the Okay.
Yeah. So here's the cool thing. 75.48 is considered a very large calculation. Therefore, we can predict, keyword predict, or keyword could be, we can estimate that gender and the amount of texting may be dependent, not independent. May be dependent. Nice, Saputo. Way to do it backwards. Cross off the N. They may be dependent. Okay? The evidence shows that there is a dependency that exists. Okay? That is the calculation of chi-square test by hand. So I would have liked to talk about some things that would hinder reliability, but we'll get back to that. Well, I could just say, you know, confounding variables, those type of things. Oh, I had the whole thing about calculating chi-squared using a graphing device calculator. Well, I will go ahead and your homework is watch the video, because I'm going to do the rest. Oh, it's one more slide. So I'm going to do the rest, and then you just watch that last 2 slides. Okay? No. Oh, the formal test of independence, showing you how to figure out information.
There's not a test.
Not a test next class, this is a formal test. All right, goodbye. Oh, shoot, I left the video running. Oh, man, I can't believe I did that. Okay, real quick. Calculating chi-squared using GC. What you need to know is this is the kind of stuff that you're going to be required to do on the IB paper. There's your example. This is how we do it on the calculator. Find the expected value. There we go. So enter the raw data into the 2x3 matrix. Then, so step 1 is step 1. You press second. The matrix button is x to the negative first, and then press edit. So click stat. And so what you do is at the very top you write 2x 2 times 3 matrix, and then after that you plug in the data below it into a matrix. Okay. Next you press stat test down to chi-squared tests and press enter. Calculate it, and there you get your chi-squared calculated value. Okay. If you go back to the matrix section, there's another matrix B that shows up. You edit that, and you can see all the expected values. It's pretty handy. There's your homework. I might add a section to this that shows you on the calculator, but that's all. All right, so I said I would add this, so I'm going to add this. Let's go ahead and create, use this and create a table for us to investigate. Let's see. Doot, doot. We're gonna go ahead and open up the calculator, which apparently is already open. And we're going to add the information into the matrix. Okay? So we click, turn it on. I'm going to go ahead and quit out of this because we are currently not using that. And what we do is we press second and matrix. Do not select this. Go over to edit, and we're going to edit the first matrix. And that matrix is going to be a 2 by 3. Okay? And now we have all these columns here. Now what we're going to do is we're going to enter in the data within the first 2 rows and the 3 columns. So 59, 71, 35. Okay. So now that we have that information in there, okay, which is step 1. Step 2, we're going to click Stat. We're going to go over to Test. And if you keep scrolling down, it's actually you can scroll up and it'll go down to chi-squared test. And what we do is we go ahead and select that, press Enter. We have our observed and our expected, and then we go ahead and calculate. And that gives us our chi-squared value of 1.132. All right. Now, last thing we can do is we can go ahead and press second matrix. And now we have a second B matrix that we can use. And so let's go over and edit. And it turns out that that is our expected values. So those are expected values, and now you have all the information. And we will learn next class how to interpret that information accurately and dependably. Thank you very much. See you later. Good.